Okay, today we're going to talk about power. We talked about work or energy, and we talked about volumetric flow. Then we're going to pull it all together with power, and then we'll be talking about efficiency before too awfully long. Okay, so first of all, power. There are several equations for power that we're really going to use. But the main one that we probably should talk about is going to be work divided by time. Now, work, if we remember, is going to be some distance times some force. So we could take that and divide it by time, and we're going to get power. Now, for SI units, it's pretty simple. We get, for distance, we get meters. We're going to multiply this by some force, which is going to be in newtons. We're going to divide by time, so we get Newton meter per second. And that's going to equal 1 watt. So 1 Newton meter per second is equal to 1 watt. For the British gravitational system, or the imperial system, we get something a little less nice. We get the horsepower. And so if we take a distance in our base unit is going to be feet, we multiply that by some force, which is going to be pound force, divide that by time, which is seconds. We get a proper unit of power. However, a horsepower is not equal to 1 foot-pound per second. It's actually equal to 550 foot-pound per second equals 1 horsepower. So 550 foot-pounds per second is equal to 1 horsepower. So that's unfortunate. That but if you don't remember that, you just remember that 550 in between. That's not shouldn't be too hard. There's 700. This is a very important one. 745 watts or 746 watts is going to equal 1 horsepower. So again, just kind of a review of units here. We have force in newtons, and actually a newton, if we remember, is a kilogram meter per second squared. We have pressure, which is going to be in newton per meter squared, and that's a Pascal. Work is in joules. Joules is a newton meter, and power is in watts, and that's a joule per second. For British gravitational, we have pound force, which is a slug foot. Should be, this is wrong right here, I just realized. Wow. A slug foot per second squared. I'm not sure what happened there. That's a typo on my part. Slug foot per second squared. Pressure is in pounds per square inch, or the base unit should be pound per foot squared, or per square foot. Work is in foot-pounds, and then we have horsepower, which is in foot-pound per second, divided by 550, which gives us horsepower. So we have a couple of power equations here that we need to look at, because power can be equal to, of course, our work divided by time, but it can also be equal to force times velocity and pressure times volumetric flow. The force times velocity is pretty simple. It's just like our other one. If we do force, like in pound force times velocity, feet per second, we're going to get pound foot per second. So pretty simple there. However, the pressure times volumetric flow rate, well, pressure, our base units of pressure is pound force per foot squared times volumetric flow rate, which is going to be in feet cubed per second. And of course this cancels out, and we get pound force foot per second. So that works out as well. So this will give us fluid horsepower. So this right here is fluid horsepower. And then both of these we call mechanical horsepower. There's one more I want to throw in there, and we have watt, 1 watt equals 1 volt times 1 amp. I'm going to write it out. So 1 watt equals 1 volt times 1 amp. Of course, there's 745 watts per horsepower, and we call this would be electrical power. And this really shouldn't be horsepower. I'm just going to remove this because I tend to say that because of the next equation on the next slide, but it's just mechanical power and fluid power. So we have some useful power equations that we wanted to throw in there. We have our hydraulic horsepower is going to be pressure in PSI times volumetric flow rate in GPM divided by 1714. We have electrical horsepower, which is just voltage times watts times divided by 746. And then mechanical horsepower is torque in inch-pounds times angular velocity in RPM and divided by 63025. So these are all just some conversion factors here. Let's write this out real quick. So these are just conversion factors. T is torque, and then N is angular velocity. So, all right. So let's look at a couple of examples here. We have a cylinder with a volumetric flow rate of 0.01 meter cubed per second. So we're working in SI units here, and a pressure of 12,000 pascals. If the cylinder has a diameter of 0.1 meter, find the velocity, force, and power output on the cylinder. So the first thing we can do is go ahead and find our area. Of course, that's pretty simple. Area equals 0.1 divided by 2. This is in meters squared. Times pi is going to give us 0.00785 meter squared. And then we can take that and find, let's say we have our pressure, so we can find our force, right? So we have pressure equals force divided by area. So 12,000 pascals equals 12,000 newtons per meter squared. And then, of course, we multiply this by 0.00785 meter squared, and we get 94.2 newtons. We have volumetric flow rate is 0.01 meter cubed per second. And we can find velocity with this. So Q equals area times velocity. So we can take 0.01 meter cubed per second, and that's equal to 0.00785 meters squared times velocity. So we just divide both sides by 0.00785, and we find that velocity equals 1.27 meters per second. As far as finding power, power output here, lots of ways we can do that. But let's just do it with do power equals force times velocity. So we have a 94.2 Newton force times a velocity of 1.27 meters per second. And we get, of course, the units is going to be Newton meter per second. And we're going to get 119.6 Newton meter per second, which goes to 119.6 watts. We can also do this in our volumetric flow rate, which is power equals pressure times volumetric flow rate. So our pressure was 12,000 newtons per meter squared. We're going to multiply this by our volumetric flow rate, which is 0.01 meter cubed per second, and we get 120, and that is in Newton meter per second, and of course that goes to 120 watts. These two are the same, just rounding error. Alright, a cylinder has a volumetric flow rate of 20 GPM and a pressure of 500 PSI. If the cylinder has a diameter of 6 inches, find velocity, force, and power. Same thing, just different units. So let's do this. 20. Let's get our units into something a little better. Let's see, our diameter is 6 inches, so let's go ahead and find area. So it's 3 inches squared times pi. And that should give us a area of 0.1963 feet. I'm going to go ahead and do this in as 0.25 feet. There we go. And squared. The reason why I just was looking, I'd done the conversion in my notes already like this, so we'll go ahead and do it this way, and that's fine. You can do this because after all, we can do 6 inches times 1 foot, 12 inches equals 0.5 feet, and that is our diameter. So we divide by 2, and we get 0.25 inches. I'm sorry, feet is our radius. So. Sorry about that. So we have this. We can of course use this to find to verify that. All right. So let's go ahead and convert our 20 GPM to something a little more usable. 1 foot cubed, 7.48 gallons, 1 minute, 60 seconds, and so we're going to get 0.0445 feet cubed per second. That is our volumetric flow rate, so Q equals. Let's look at our pressure. So we have pressure equals 500 pounds per inches squared, and we're going to multiply this by 144 inches squared is 1 foot squared, so we're going to get 72,000 pounds force per feet squared. And so we can find our velocity. First thing we probably could go ahead and do is find our force actually. So we know that pressure equals force divided by area. So we have our 72,000 pounds force per feet squared. And then of course we can times this by our area, which is 0.1963 feet squared. And we get a force of 14,137 pounds of force. Q equals area times velocity. So we have 0.0445 equal, that would be in feet cubed per second. Equals our area. So 0.1963 times velocity, so we just divide, this is in feet squared. So to find velocity, we just divide both sides by, right here, 0.1963, and we're going to get our velocity is going to equal 0.2266 feet per second. So to find our power, two ways we can do it. We can do force times velocity divided by 550 gives horsepower. So power equals our force, which was, we calculated that to be 14,137 pounds force, times our velocity, which was 0.2266 feet per second. And then of course we're going to divide all of this by 550. And that's going to give us our horsepower, which is 5.8. We can also do pressure. Time volumetric flow rate. So pressure was 72,000 pounds force per feet squared times volumetric flow rate, which was 0.0445 feet cubed per second, divided by again 550, and give us 5.8 again. Of course, you could also use the other formulas that we used with pressure and PSI times volumetric flow rate and GPM divided by 1714. So you could have done pressure and PSI, which was 500, times flow and GPM, which was 20, divided by 1714. So we could go power equals, by the way, power is a lowercase b, equals 500 PSI times 20 GPM divided by 1714, that's our conversion factor, again equal to 5.8 horsepower. Okay, that's all I've got for you today. If you have any questions, let me know.